In number 12, we're provided with a function and we want to match it to the graph that models this function. So remember that cosine divided by sine is cotangent. And I also want to remind you that both the basic function tangent theta and cotangent theta have a period length of pi. Now, this particular function is not just the cotangent of theta, it's the cotangent of pi theta. So in order to figure out the period length of this function, we're going to take pi and divide it by the value in front of theta, which happens to be pi. Pi divided by pi is 1. Just a little side note, if this was just sine, or if this was cosine, or the reciprocals cosecant and secant, those four functions have a period length of 2 pi, but tangent and cotangent, these basic functions are a distance of pi. So again, we don't just have the cotangent of pi like this, we have a value in front. So to figure out the period length of this particular function, I take pi and divide it by the value in front, which is pi, and now I have a period length of 1. Let's see what we can cancel out. Okay, so this is the distance here. We can see one cycle here is a distance of pi. No, we want a distance of 1. So I can cancel out A. B, the distance is pi. I can cancel out B. Now C and D, the distance of one cycle is 1. The distance of one cycle is 1. You can see that if I narrowed it, that's one cycle. It's a distance of 1 cycle. Now the only difference here is that distance, that cycle, it increases, and here the cycle decreases. So how do I determine which one it is? Well, let me grab a piece of paper and let's go back to thinking about cotangent and looking at this unit circle. Okay, so let's start at 0. Let's start at 0. At 0 for both of these functions. Okay, so cotangent, we know, of any function is going to be the cosine divided by the sine. So let's start at 0. If I take the cosine and divide it by the sine, it's undefined. That'd be a vertical asymptote. And we can see that both of these functions have a vertical asymptote at 0. Great, okay. Let's go to this next very common position, which is 30 degrees. And let's take the cosine and let's divide it by the sine. When we divide, we are going to turn division into multiplying and flip, and I have simply radical 3. So this has a cotangent that's undefined. I'm going to do this in order as I go up here. So at 0, it is undefined. Now at 30 degrees, or pi over 6, we have a value of radical 3, and I know that's approximately 1.7. Now let's come up here to 45. If I take the cosine and divide it by the sine, at 45 degrees, I'd get an answer of 1. And so, by the way, look at how it's going down. See how it's decreasing 1.7 down to 1? Let's go to 60 degrees. Now, at 60 degrees, I'm going to take the cosine and divide it by the sine. And just like I did at 30 degrees, I keep the 1/2 in this case, turn division to multiplying and flip. The 2's are going to simplify, and I have 1 over the square root of 3. Now, 1 over the square root of 3, I did it on my calculator. 1 over the square root of 3 is approximately 0.57. So we can see as I move forward, as I move forward on this line, that the output values are going down, which means the output values are decreasing. So which one from 0 to 1 has decreasing values? This is increasing. From 0 to 1, it is decreasing. The output values are going from large numbers and it is decreasing. That means the correct answer here is option D.